Hello everyone. As was said, I am going to talk about performance and scaling software as a service web application. And let's just go right in. First off, a little bit about me. My name is Anže. I am from Slovenia, but a year ago I decided to just move to Lisbon because here it's much nicer. The weather is amazing. I think Lisbon has 1,000 hours of sunshine more than Ljubljana, which is the capital of Slovenia and where I lived before. So I am enjoying the life here a lot more than I did back home. And I don't think I'll be going back anytime soon. Forward. So I work for a company that's based in the US and it's named Reciprocity. And this talk is basically going to be about how we managed to scale a product that was developed in this company in the last 5 years. So Reciprocity is a bootstrap startup. We never had any VC funding. We started out working for a single customer and then moved from there. When I joined, there were 4 engineers at the team, and now we have 20 of them scattered all around the world, most of them in the US and in Slovenia, plus me in Portugal. We basically went from one customer whom we started with and expanded that to 100. So because we don't work with regular people, we work business to business. Having 100 customers is quite an achievement, and we're really happy that we got so far. So now I'm going to talk a little bit about the product that we made, which is called ZenGRC, because it will I need to explain a little bit about what the problem is that we were trying to solve, so that I'll be able to show why we had to take the technical decisions the way that we did. So ZenGRC basically helps companies manage their compliance and risks. GRC stands for Governance, Risk and Compliance. And it's basically helping organizations to follow regulations that are made by the governments or other organizations. One good example of such a regulation right now is the GDPR. The General Data Protection Regulation that's been making quite a few headlines. And basically the point of ZenGRC, or our app, is you have to be compliant with GDPR, and we take that regulation, we split it into tasks and give you those tasks to do so that you know exactly what the steps are for you to be compliant. And that's basically the problem that ZenGRC is at least attempting to solve. So that lawyers speak, transform it into actionable to-dos. That's our main goal. And we don't cover just GDPR, we also cover other kinds of regulations and standards, like the payment card industry standard, the PCI, the FedRAMP, and there's a bunch more. So our main competitor in this space right now are basically spreadsheets. A lot of companies, instead of using a specialized tool to do this, they basically just use a spreadsheet. That's how they track all the evidence, track everything that needs to be done and all the data that they need to collect. This of course works to some degree, but it's probably not the best user experience. So what were the challenges that we were facing when developing this application? So ever since the beginning, we kind of had a very high developer churn. A person would come to the company or to the project, work for a few months, write out a few features, and then they would leave. Which meant that the rest of the team would kind of have to maintain the code that that person wrote. Reasons for that were kind of complicated. We as a company weren't always deciding who is going to work on the project, because our biggest contractor kind of directed what needs to be done and who's going to work on it. The way that we solved this was to basically stop being a services company, so stop doing services for that one big customer and try to get new customers that will pay us to do the work that we want to do. That one big contractor also had a lot of wishes, a lot of feature requests all the time coming in, so we were always one step behind, and we were always behind schedule and rushing to do them. And this probably sounds like everyone's job right now, right? But that's one of the excuses that that I at least have for the problems that we were encountering. And when I joined the project, the code base already had 42,000 lines of JavaScript. And in the 5 years while I was there, we kind of doubled it. So that's also one of, dealing with that much JavaScript also is sometimes kind of a problem. And all of these factors kind of brought us to the problem of performance. Our app started to become kind of slow, and we had to figure out how to fix it. So the way that you deal with performance problems is you first need to figure out what you're actually trying to achieve and what your domain is. Because certain solutions will work well on one domain, but won't work that well on others. Let's say if you're so in our example, we were making a web application that is being used by a few people inside a big company when they're at their desks working on their computers, and that was basically the main use case. We didn't have to worry about people working from bad Wi-Fi connections, because that was not what the users were on. And we didn't have to worry about people on mobile devices, because when people are working on these kinds of things, they always have a computer. So that's why we didn't focus on making, let's say, our JavaScript payload as small as possible, because that just wouldn't make any difference on our load, or it wouldn't make a difference for the people using it. Our JavaScript payload is like 3 megabytes right now, and we feel bad about it, but it doesn't really make sense to go and optimize that in the way that for us right now. We might do it at some point, but right now we have different bottlenecks to fix. And secondly, you have to know your users. You have to know what the users are trying to do within your app, so that you can optimize the experience for those cases. If you have a very slow part of the app that hardly anyone ever touches, maybe because it's slow, maybe because it's just not that interesting, you don't really have to drop everything and fix that. You're better off focusing on the part of the app that the users interact with more often and that is more important for them. So that's why you need to know your users before you start tackling performance issues. And another very important thing that actually made everything quite more difficult is you have to know the data that the users are working with. So this is basically the lab versus field data problem. In our case, when the developer was working on a feature, they worked almost on an empty database, which meant that everything was super fast. You couldn't detect any performance issues there. But when we deployed that set feature into production, where there was a big database with thousands of objects, it started becoming extremely slow. So the way that we tackled this was, of course, to mimic production data in the development environments and forcing people to use a lot of data locally as well, if it's possible. So the first problem that we tackled with was the 10-second load times. So our main issue was that when you opened our app, when the user opened our app, it took 10 seconds for it to open up. And this is basically the performance step in Chrome. And you can see that you can't really see the numbers here, but it's 10,000 milliseconds right here. So this big block of JavaScript, this block of CPU rendering, and here is basically what was causing the most issues. And when we actually started to investigate, we figured out that this bit of code here that was being executed was because of the little numbers right here. Because the way that we were calculating and making these little tab icons work, it actually took a huge amount of CPU time. Even though the data that we ended up calculating in these steps were only used once the user clicked on those little thingies. So that was kind of easy to get rid of. We just stopped doing that, and the performance went up by quite a lot. One of the reasons why this was so slow was that we were reading from local storage when we were loading those numbers, and that was because if you click the tab, you got a list with columns, and you could have your own preferences saved locally in the browser. So that was a feature request at some point. Somebody came in, made it, we merged it, and then we all forgot about it until we started looking at performance issues. So we kind of got that out. Another problem was that we used basically a model. Our JavaScript framework that we used, which was CanJS, used like an abstraction around models, and basically loading all that data into the JSON data that we got from the server into the representation of the model was also causing issues, so we had to kind of work around that as well. But the main lesson here was basically that we should never have used CPU time for things that aren't even displayed. So for rendering those little icons, we don't have to compute what happens when you click on those icons. And that was basically the main takeaway from this particular issue. And once we fixed this, our JavaScript load time went down quite a lot. So this is, now we're like at a 2-second limit, and that's, so far it's fast enough. We also changed the design a bit. Oops. Oops. Let's go back a bit. Oh. Sorry about this. Okay. We also changed the design a little bit, but that was just mostly superficial changes. So the next thing that I want to point out is network requests. You should always be careful with how many network requests you're making. And in this case, for loading this list of items, we had to make all of these network requests to get all the necessary data. This, of course, took quite a long time, and we had to figure out how to fix it. In this particular case, we needed to come up with a new API endpoint that would get us everything that we needed in a nicer way. Plus, so that we could also actually get exactly what we need from the server. And once we fix this, why is this? Sorry. So once we fix this, the network, you can see that the network requests went down quite a bit. And now we are going to get to our biggest problem that we had, which is the list view. So this is the view. This is basically the main UX of our application. The thing that the users use the most to interact through our app. It basically lists all of the objects, all of the tasks that you have in the system, and it shows how those tasks relate to other objects in the system. So we're basically trying to display a big graph-like data structure on the front end like this. And we were trying to make this thing as fast as possible while it was loading a lot of items. Before the first implementation of this didn't work so well. In fact, it caused a dreadful snap video when the user tried to load it with 1,000 objects. This was basically because we were inserting a lot of DOM nodes into the DOM tree, and we basically used up all the RAM that the Chrome process had. That was terrible, and we of course had to fix that overnight. And we basically came up with an approach of lazy loading. And I think I should have a video here. Yes, so basically lazy loading loads the tree, but only renders only the titles of the objects, and then when you scroll up and down, the rest of the data kind of appears as you scroll. This was a solution that required a bit of work, but we ended up implementing it and it worked well. That was until the users tried to use it on a very long list, so more than 2,000 objects, so 2,000 rows. At that point, it still started to become slow and sluggish. As you can see in the video, you almost think like something is wrong because it takes so long to render. And at this point, we were basically at we had to decide how to fix this. So we know that there is a possibility for us to improve this. We can, instead of using the framework that we use to render this, we can go around it and maybe do the operations, the DOM operations by hand. Maybe we can, I don't know, rewrite everything in React. Or maybe we can come up with another solution. And that another solution is basically very, very simple. Maybe just use pagination for this. We were considering this from the very beginning, but the only reason why we were avoiding it was basically because our users were used to this. So they were used to spreadsheets and they were used to just scrolling up and down all the time. And trying to convince them that maybe seeing something like this where you have some icons, some numbers at the bottom isn't actually that bad. Now we could have rewritten everything in React. It might have been better, it might not have been. We could have spent another month or so improving the lazy loading solution. That there are definitely ways to make that faster. But at the time, the best approach for us was, and the simplest one, was just to give in and implement the pagination thing. And then just explain to the users, well, you can't really scroll infinitely, but you can you can filter the data in a different way. Some of the users were actually upset about this, but they got used to it, and now they don't even think about lazy loading anymore. So it actually ended up being a good solution. And yeah, there's actually a little video showing that it now works without much problems. So to quickly recap, to deal with performance issues, you must have the metrics, you need to know what's slow, and you need to understand user behavior. And when you think about user behavior, what the users are doing right now might not always be true, might not always be the best, or there might be other options. You always have to make sure that the CPU time is used for good, so for things that will actually show up on the page, and not and don't spend it on things that ended up not being rendered. And of course, when you're fetching data from the server, only load the things that you need. That will sometimes require you to change the APIs, to make new APIs, and so forth. But that's simply something that you will need to do. And when doing all of this, I think you have to keep in mind that doing a complete rewrite of the system is almost always a bad idea. Because if you stop working on features, stop working on incremental improvements, the users will give up on you, because they can't live, usually they can't live with the current state of things for another year or two. Rewriting 40,000 lines of JavaScript that we had already in the app would have taken us way too long, and if there were no updates between that time, we would be basically dead in the water. And that's it for my talk. If there are any questions, I'm happy to answer them. Otherwise, you can also contact me through Twitter or email.